Hi, this is Stan Forster, your instructor. We're in this module 4, we're going to be looking at solving equations. And we're going to need some skills foundations. We're going to look at the addition principle, the multiplication principle, and how to use them together. Okay, the addition principle states that adding the same quantity to both sides of an expression doesn't invalidate the expression. You can think of like a set of weight scales. If they're already in balance and you add an ounce to one side and an ounce to the other, it doesn't change anything. Okay, so here's our first example. We're going to start with the expression 5y plus 3 equals 18. Now we can look at that. We just do a little math in your head and you see that the solution is y equals 3. Go ahead and plug that number in for yourself. Check that the proposed solution works. Okay, so we know what we want to know what the end of this process looks like. It's going to look like y equals 3. But how do we get there? Okay, so the addition principle tells us that adding the same number to both sides of the equation will not change the solution. So if we start with 5y plus 3 equals 18, well, let's add a negative 3 to both sides. Now you'll see in a moment why I chose negative 3. I could have added 10 to both sides. Minus 3 is going to be a little more useful. So 5y plus 3 plus a negative 3 equals 18. And again, we have to do the same thing to both sides. So plus a negative 3. That becomes 5y plus 3 minus 3. And you're beginning to see why I chose minus 3, negative 3. 18 minus 3. And let's go ahead and evaluate what we can. It ends up with 5y equals 15. Already, that's a much simpler expression. And we can go on and apply the multiplication principle. Okay, the multiplication principle states that multiplying both sides of the expression will not change the solution. Okay, again, think of your balance scales. You have a pound on each side, and they're balanced out. It's all good to go, right? Now, if you double the amount of stuff on either side, is it still balanced? If you take 1 pound becomes 2 pounds on the left side, 1 pound becomes 2 pounds on the right side. Yeah, it's still balanced. Okay. So let's take when we left off, we had 5y equals 15. Now I'm going to multiply both sides of this equation. I'm going to multiply both sides of this equation by the reciprocal of 5. Okay, so we obtain 5y times 1/5 equals 15 times 1 over 5, or 1/5. All right, I'm going to get rid of that red there so it looks normal. And then we're going to distribute out so 5y times 1/5 is 5 over 5 times y. And on the other side we have 15 divided by 5. 15 divided by 5. Let's go ahead and evaluate that. 15 divided by 5, that's 3. 5 divided by 5 is 1, and we just simply drop the notation y equals 3. Okay, and we confirmed. We confirmed what our solution was that we obtained at the beginning. That is what the solution looks like. Okay. Caution, when applying the multiplication principle, make sure that you multiply everything on both sides of the equation by the same number. As a matter of fact, I'm going to show you in a few moments, I'm going to show you a common error that people run into. All right. Okay, let's return to our previous example. Only now we're going to reverse the order of the principles we applied to solve the problem. Okay, we start again with 5y plus 3 equals 18. If we apply the multiplication principle first, we should think of both sides as being surrounded by parentheses. So, open parenthesis, 5y plus 3, close parenthesis, equals 18, open and close parenthesis. Now we're going to multiply both sides by 1/5. All right, and you can see here where the issue comes in. Some people will simply divide both 5y by 1/5 and then forget to divide 3 by 1/5, or 3 by 5. Okay, so let's go ahead and let's just do it correctly first so you can see the correct way. So 5y times 1/5 plus 3 times 1/5 equals 18 divided by 5. Again, 5 over 5y, that's just 1, and it goes away down here. This portion is now 3/5. and 3/5, 18/5 and 18/5. Let's apply the addition principle. We're going now to get y by itself. We're not going to add a -3. We're going to have to add a -3/5. We're going to add a -3/5 to both sides. So y plus 3/5 minus 3/5. 18 plus 3/5 plus a -3/5. Okay, these are all over a common denominator, so we can just simply take 18 minus 3 over 5, and that's 15 divided by 5, or 3. Okay, on this side, 3/5 minus 3/5 is just 1, is 0, and we're just left with y over there on the left-hand side, and we end up with y equals 3. You obtain the same solution, which is what we expect. We said that applying the addition and multiplication principles leaves the solution unchanged. Okay, so even though it's more complicated, we have to deal with fractions and a distributive property of multiplication, and adding and subtracting fractions. It still works, but it's if you have any problems with adding fractions, or if you've had problems in the past with remembering the distributive property and multiplying both terms when you multiply a side of an equation, you just leave yourself open to more possibilities for error. Okay, so I'm going to show you this common error here, the one that I was talking about before. This is the one you should figure out a way of never making yourself. Okay, so we go back to 5y plus 3, that whole quantity times 1 over 5 equals 18 times 1 over 5. And what we did here, this is what I see sometimes, is this is 5 over 5y plus 3. Okay, what they did was they forgot to divide 3 by 5 as well, equals 18 divided by 5. Okay, so basically you didn't apply the multiplication principle. The student who did this one didn't apply the multiplication principle because this isn't 3 over 5. Okay, and that's wrong. Okay, we're going to apply it again. We're going to solving the equation of a line. The equation of a line has a form y equals mx plus b, where m and b are constants. Okay, let's apply these principles that we worked with before to obtain to an equation to obtain this standard form. All right, so we have a relationship between the variables y and x. So y plus 3 equals 5x plus 7. We're going to add a -3 to both sides of the equation. Okay, and in red here is where we're adding the -3. Okay, we'll just go ahead and we'll drop that bright red text color. So we have y equals plus 3 minus 3. Of course that's going to go away. And then you see that y is isolated by itself. 5x plus 7 minus 3. Well, 7 minus 3 is 4. And then now we have, with m equal to 5 and b equal to 4, we have that y equals mx plus b. And we indeed have one of the standard forms for the equation of line. This is also called the slope-intercept form. Okay. As an aside, an equation of line has multiple solutions. Instead, there are pairs of solutions, pairs of values of x and y, which are solutions. On a coordinate graph, these solutions form a line, which is why we call it the equation of a line. For instance, here's an example of the multiple solutions. If we substitute x equals 0 into the expression, we obtain y equals 5 times 0 plus 4, or y equals 4. So the ordered pair, x equals 0, y equal to 4, that ordered pair, or coordinates, is the solution to the equation, is a solution to the equation. We substitute y equals 0 into the expression, we see 0 equals 5x plus 4. Well, what are we going to do there? We're going to take that, we're going to apply the addition principle. We're going to add a -4 to both sides. So 0 plus a -4 is equal to 5x plus 4 minus 4. Getting closer there, we're getting closer to x all by itself equal to something. Then the multiplication principle, we're going to basically multiply both sides by 1/5. So -4/5 equals 5 over 5x, or just x. And then for the sake of display, I'm going to go ahead and I'm going to evaluate that 4/5. That 4/5 is actually equal to minus 4/5 is equal to actually equal to minus 0.8. Okay, you can think of this. Okay, so if we multiply the top and the bottom of this by 2, that would become 8/10, and the 0.8 becomes more obvious. Okay, so the ordered pair negative 0.8 comma 4, that ordered pair is also a solution to the equation. And here I'm going to illustrate that a little bit. So we can imagine this here as this graph for 5x plus 4. We can imagine that y is equal to 5x plus 4. And we can see that when x is equal to 0, right here on this line, so x is equal to 1 here, and it's 1 minus 1 there. So right here, x is equal to 0, y is equal to 4. Okay, well, what happens when y is equal to 0? Well, it's 2 here and minus 2, so right here at the origin, y is equal to 0. But where does this line cross the x-axis? And we can see it's somewhere between minus 0.75 and minus 1, much closer to minus 0.75. And so the solution minus 0.8 or negative 0.8 is a reasonable solution, at least from inspection of the graph. Okay. If you'd like to produce a graph like this, just go to Google and search for y equals 5x plus 4, and Google has a graphing function. I think it has a function for everything except babysitting. Explore that. If you have any questions, please let me know. Ask to have questions in the discussion board, and we can work some problems together.